All right, guys, so I decided that I'm just going to start doing the first page of all of the problem sets so that I don't overwhelm you with information, and so maybe it's easier to just kind of keep up with everything. So yesterday we did lesson 18 problem set where you compared fractions on the number line that had different denominators, and we learned that we would half each section again to create more parts. So today we're going to be creating number lines with the same denominator and comparing fractions with the same denominator again. This lesson goes back to the one we did last week on Thursday, I believe it was, lesson 17, and y'all did great with it. So I don't see any problems with this one. All right, so looking at the first one, we're going to divide each whole into halves. Remember, we're not dividing the number line into halves. We're dividing each whole into halves. So I would have this one, and this one. And remember, to make halves, we just draw one line. Then I would go and find these specific fractions that they've given me. 0 halves, 1 half, 2 halves is at 1 whole, 3 halves is here, which is one of the fractions they want me to label. 4 halves is here, which is another fraction they want me to label, and 4 halves is equal to 2, because remember, 4 divided by 2 is 2, or 2 times 2 is 4. 4 over 2 is another way to write division. And then 5 halves is the last fraction they want me to label on this number line. So I'm going to go to fourths. Notice my number line starts at 0 and goes to 3. So I would ask you, are there any whole numbers in between? And you would tell me there are. We need to do 1, 2, and 3 is already done. My 2 is a little further over than I would like it, but I'm in pen, so I can't change that. Remember, we're all human. Sometimes we make mistakes, guys, and I know that y'all don't always make your number lines perfect either. So let's look at dividing each of these into fourths. So we're going to do 3 lines in each. And then we're going to label the fractions they give us. We're starting at 0. So 0 fourths, 1 fourth, 2 fourths, 3 fourths. 4 fourths is at 1 whole. 5 fourths, 6 fourths would be here. 7 fourths, 8 fourths, 9 fourths would be here. 10 fourths, and 11 fourths would be here. On the next one, I'm in eighths, and again, I am dividing my number line with whole numbers in between. I've got 0 to 3. I need to label my 1 and my 2 a little further over this time, and then each need to be eighths, which is 7 lines, because we always do one less line. Okay, then I'm going to find 24 eighths, 19 eighths, and 16 eighths. And remember, it's easiest here if we just go to the ones we know. So we know 16 eighths is at 2, because 16 divided by 8 is 2. And then I can just count up from 16 eighths. 17 eighths, 18 eighths, 19 eighths is here. And 24 eighths is going to be at 3 wholes. Okay, now down here, ideally, I should be able to compare my fractions with my number line. But because we're not perfect, it might be off. Like, look at my 2 versus my 2 here, because I made this 2 too close over here. I'm going to show you a trick that is not necessarily Eureka, but just old school math on how to compare fractions. So first, let's start with the ones that have like denominators. Obviously, 6 fourths is less than 9 fourths, so I'm going to open my mouth up to 9 fourths or point my beak to 6 fourths. 5 halves is obviously greater than 3 halves, because 5 is more than 3. 19 halves is greater than 19 eighths is bigger than 16 eighths. So I open my mouth up to 19 eighths, point my beak to 16 eighths. Then I get to someone where the denominators are not the same. Well, I know that 16 eighths is equal to 2, and 3 halves is less than 2. 16 eighths is at 2, 3 halves is before 2. So 16 eighths is bigger than 3 halves, and so I'm going to open my mouth up to 16 eighths. 9 fourths is after the 2. 19 eighths is also after the 2, but 19 eighths is a little further than 9 fourths. So we would say that 19 eighths is larger. 4 halves and 16/8 are both located at the 2. 4 halves, 16/8, so they're both equal to 2, so then these two would be equal. Then we have 6/4 before the 2 and 16/8 at the 2. So 16/8 is greater because 6/4 is less than 2 wholes. 5 halves up here and 9/4. Both are after the 2, but the 5 halves is a little after. Now this is one where I could check myself, and I'll show you the trick on that. And I've showed you this before, and some of you were a little confused by it, so I hope that this doesn't confuse you. If it does, ignore it. But for you parents, I know that you remember this trick. We have our butterfly trick. When we are comparing fractions, we can draw a butterfly connecting our numerator and denominator from the opposite fraction. 5 times 4 is 20, and 9 times 2 is 18. So 20 is greater than 18. So 5 halves is greater than 9/4. So that is not a conceptual understanding. It's not really understanding the concept of 5 halves being more than 9/4, but it does help us know for sure that when looking at our number line that our 5 halves is more than 9/4 because it's to the right of 9/4. Okay, then our last fraction is 24/8, which is at my 3, and 11/4, which is before 3. So 24/8 would be larger. Open my mouth up to 24/8, point my beak to 11/4. All right, guys, so here is your lesson 19 problem set. I will not do the second page. Watch the Zern video for this one as well. I hope you did prior to watching this. If not, go do it now. And for tomorrow, we are just going to do our week 27 math for today. I will complete it in a video, so try to complete it prior to watching the video, and you can check your work with me. I hope you guys are having a great day. Bye.